Hello, and thank you for joining us today. My name is Yelena, and I am from Belkasoft. Today we are talking about one of the most popular chat apps, WhatsApp. It became popular with almost 2 billion users around the world, and it boasts of its user privacy and security features as end-to-end encryption. Even though WhatsApp has its user policy open to all public and the company states that users can access its services only for legitimate and authorized purposes. Criminals use this app for illegal information distribution as well as for encrypted calls to coordinate illegal activities, including drug trafficking and people smuggling. During our webinar, we will go through the following topics. Uh, First of all, what is WhatsApp, how it evolved during the last years. We will talk about its key features and end-to-end encryption specifically. Then we will talk about what kind of WhatsApp artifacts can be extracted across various platforms, including iOS and Android, as well as PC and Mac. And in the end, we will have demo session explaining how you can extract and analyze WhatsApp data with Belkasoft Evidence Center on various platforms. Let us start with a Belkasoft brief description. Belkasoft is a team of professionals in digital forensics, data recovery, and reverse engineering. The company mostly focuses on creating technologically advanced and easy-to-use products for investigators and forensic experts. The first Belkasoft product was released in 2007. Belkasoft is presented with 3 offices in the US and Europe. Our customers are government agencies and federal departments, police and law enforcement agencies. There are several thousand Belkasoft customers all over the world. Here on this slide you can see some of our significant US customers, some big names like the US Department of Homeland Security, NASA, Deloitte, KPMG. And outside the US, our customers are Air Canada, the Sussex Police, the government of the Hong Kong, and many more loyal customers. Our flagship product is Belkasoft Evidence Center, which is an all-in-one digital forensic and incident response software. Belkasoft Evidence Center can automatically discover, extract, and analyze evidence from various sources: computer hard drives and disk images, and memory dumps, mobile devices, and chip-off dumps. Since Belkasoft provides low-level access to hard drives and system structures, investigators can still extract data that was deleted by a suspect. And Evidence Center can collect more evidence than any individual tool competing in the same class. In the digital forensic industry, Forensic Forecast is a popular magazine that rewards outstanding achievements through awards. This year, Belkasoft is one of the 3 nominees in the category Digital Forensic and Incident Response Commercial Tool of the Year. I invite you to vote for Belkasoft Best of Breed Solution Evidence Center. The link for voting will be provided in the chat right now. So, as of 2019, WhatsApp is the most popular global mobile messenger app worldwide and one of the messaging apps in the Facebook ecosystem. WhatsApp tallies 500 million daily active users and 2 billion monthly users in 180 countries. WhatsApp is mostly popular, especially in emerging markets, with the largest number of users such as India and Brazil. Other countries where the app is widely used as well are the US, Russia, Indonesia, and many more countries. So WhatsApp is running all Android versions starting from 4.0.3 and iOS starting from iOS 9 and Linux-based KOS. Like any other chat app, WhatsApp was created to allow users sending and receiving text messages. There are group chats as well, which are designed to share messages, videos, images, and documents with up to 256 people at once. With WhatsApp, users can have either voice or video calls, as well as send voice messages. What's more, users can launch WhatsApp on their PCs and laptops, in web browsers, and as a desktop applications. There are also such useful security features like backup data in cloud services, two-step verification, and end-to-end encryption, which we will cover later. WhatsApp is evolving all the time, and recently they released the new feature Payments, which is available only in Brazil for now. The other upcoming features which can be of importance for digital investigators include multiple device support, when a user will be able to launch an app on several devices simultaneously, WhatsApp QR code, with which users will add contacts by scanning QR code, and self-destructing messages, the functionality similar to what Telegram and Signal apps have. So, as I said previously, at the heart of the technology of WhatsApp is encryption. So, encryption is a method of protecting digital information as it is stored on a device or transmitted across the internet or other computer networks. When data is encrypted, it is converted to another form or code to prohibit unauthorized access. A decryption key, such as a password or numeric passcode, must be submitted to retrieve the protected information. Technically, it converts plain text to ciphertext using cryptographic keys. So there are two types of encryption commonly used. Symmetric encryption, which uses only one key and all parties use that same key for data encryption and decryption. And asymmetric encryption, which is also called public key encryption. It involves two keys. One is private and the other is the public key, which is shared publicly. There are many legitimate and necessary uses for encryption. For example, encryption is vital for protecting online commerce and safeguarding government records, and it is a vital tool for preventing many types of online crimes. However, some criminals are using encryption methods to prevent police from accessing incriminating digital evidence. For example, perpetrators are increasingly using encryption software on devices storing images of child pornography. So, WhatsApp uses a Signal protocol developed by Open Whisper Systems, and at the heart of the technology lies end-to-end encryption. End-to-end encryption is a type of asymmetric encryption, so you have the two keys. A public key, accessed by anyone with access to a server, such as with a messaging platform, and a private key, accessed only by each of the two parties involved in a message. Let's have a look how the process of end-to-end encryption looks like. So when the user first opens the WhatsApp, two different keys, public and private, are generated. The encryption processes take place on the phone itself. The private key must remain with the user, whereas the public key is transferred to the receiver via the centralized WhatsApp server. The public key encrypts the sender's message on the phone even before it reaches the centralized server. And the server is only used to transmit the encrypted message. The message can only be unlocked by the private key of the receiver. No third party, including WhatsApp, can intercept and read the message. So we understand that the new reality is that much of the digital evidence from mobile devices and online apps will be encrypted. The number of lawfully seized devices that remain inaccessible due to encryption is not known exactly. For this webinar, I managed to find some US statistics. The FBI estimates that during 12 months in 2016 and 2017, it could not access the contents of more than 6,900 mobile devices connected with criminal investigations because of encryption, and it impacted any kind of investigations. The table on the slide shows that during the period between 2014 and 2017, the Manhattan District Attorney's Office had discovered 3,882 devices running Apple and Android operating systems. More than half were locked using encryption. Law enforcement agencies and police have advocated giving police backdoor access, for example, a special decryption key. So this backdoor access should help encrypt data stored on the devices of criminal suspects. Many tech companies and privacy advocates, however, argue that a method for backdoor access could be exploited by hackers and compromise users' privacy. Let's proceed our webinar with the second part where you will get more details about WhatsApp on various platforms. We start with WhatsApp on Android. On smartphones running Android, WhatsApp stores its chat database in a sandbox. New Android devices are configured to exclude that chat database from ADB backups, and it means root access is required to access the chat database. There are three potential cases which can help you to get access to the WhatsApp data. To downgrade WhatsApp to get an unencrypted backup file, to decrypt an available backup, and to access the original database. Let's go through every potential case separately. So the first one, to downgrade WhatsApp to get an unencrypted backup file. There is a method to access the WhatsApp database on an old non-rooted smartphone. The encryption feature in WhatsApp appeared relatively not long ago. So you will need to download the previous WhatsApp versions and try to bring back the unencrypted database to the host. You will be able then to extract WhatsApp data from the created file. There are two disadvantages of this method. It will not work on your Android devices, and it's quite complicated and unstable and may lead to the loss of user data. The second case is to decrypt an available backup if you have the means to do so. Some Android devices may contain so-called standalone backups, which were created for WhatsApp. Those backups are usually encrypted. Encrypted WhatsApp backups usually appear as crypt XX, where XX stands for some digits, 1, 2, and 12, etc. To access the backup, you have to decrypt it using an encryption key. This key is stored in the WhatsApp sandbox, which can only be accessed with the superuser privileges and in case if the device has been rooted. The third case is to access the original database if the device is rooted. If you have superuser privileges, then you can get the required artifacts right from the original WhatsApp database in the application sandbox, so you don't need to get data from a backup. So let's find out where WhatsApp keeps its data on Android devices. WhatsApp application files on Android devices are stored in user data directories. Regular user data is stored there. You can also find some subdirectories and program files in the folders along this path: data/data com.whatsapp. There are two important databases also. First is WA.db, and from this database you get to access the full list of the WhatsApp users' contacts, phone numbers, display names, timestamps, and similar details. The other database is msgstore.db, and from this database you get information on conversations or sent messages such as contact numbers, the contents of the messages, status, timestamps, information on attached files, and similar data. One more thing to mention is that WhatsApp can store artifacts on an SD card. It happens when space on a smartphone's memory is limited. In this case, you will find a WhatsApp folder on the SD card's root directory. In that folder, you will see the Share, Trash, and Databases subfolders. Share stores copies of files sent to other WhatsApp users. Trash keeps deleted files, and Databases stores encrypted backup copies. And that's it for WhatsApp on Android. Let's go further with WhatsApp on iOS. There are also three potential cases for WhatsApp on iOS that will be reviewed during this webinar. The first potential case is to get the backup from iTunes. The easiest method to access WhatsApp conversations on iPhones is to acquire and analyze the backup from iTunes. The WhatsApp data in such backups are not encrypted. If a password was set, you will have to identify and enter the password. You can try to recover it or reset it on the device. The second potential case is to get the backup from iCloud backups. WhatsApp data can also exist in iCloud backups and is similar to iTunes backups. They are unencrypted. But to access a user's iCloud, you will need to enter the user's credentials and use two-factor authentication or an authentication token. In any case, once you've got access to a user's iCloud, it will be easy to retrieve any WhatsApp data. And the third potential case is to get the standalone backup from iCloud or similar storage facility. Some users configure WhatsApp on their iOS devices to create standalone backups, which are stored on the iCloud drive. WhatsApp standalone backups on iCloud drives, as well as on Google Drive, OneDrive, and other cloud storages, are encrypted, so you will have to decrypt them first to view the conversations in them. In contrast to Android devices which store WhatsApp data in multiple SQLite databases, iOS devices store all WhatsApp data in a single database which is called Chat Storage SQLite. In this database for WhatsApp, there are two most important tables that are called ZWA Message and ZWA Media Item. They store items containing data corresponding to messages, sender and recipients, timestamps, geolocation data, location of shared media, and so on. If the WhatsApp data exists on iTunes backup, then you can access most of the relevant information from the chatstorage.sqlite database inside the backup. And in this case, the file exists along this path, or you might find it displayed in some programs path this way. Besides the chat storage SQLite database, you should see the contacts SQLite data in the same location. You are able to extract some additional details about a user's WhatsApp contact from this database. WhatsApp is more popular on smartphones, though some of the users prefer to launch from time to time it on computers. In fact, there are millions of people still using WhatsApp on their PCs and Macs. That's why WhatsApp on computers can be of interest for a digital investigator. There are two ways to launch WhatsApp on Windows and Mac computers: WhatsApp Web Client and Desktop Application. Both the web client and desktop application are extensions of the WhatsApp application installed on a mobile device. They mirror the activity on the smartphone. In case a mobile device gets disconnected from a network, both web client and desktop application will become inactive. Please note that to search for and analyze artifacts from a Mac, you will need a digital forensic tool that supports APFS system, and our Belkasoft Evidence Center supports it. You can find the WhatsApp desktop application files along the path I present on the screen. And the path which will help you to find the WhatsApp web client files is on this slide. Web browsers always leave artifacts such as cache, history, logs, and cookies. In one investigation, multiple browsers can be installed on one computer, and those browsers can store or present information in different ways. Moreover, they may keep their artifacts in different locations. And a user can also have multiple browser versions on his or her computer, so dealing with all of them simultaneously can be tricky. When you research browsers, you can identify the browsers that were used and locate the artifacts corresponding to them. A digital investigator can be interested to figure out the time format used within the files and browsers applications. In this case, you will get an accurate picture of the events that took place. You can also access and analyze WhatsApp data from first the system registry, which keeps records of installed programs, prefetch and LNK files, and prefetch files contain the following important metadata, like the name of the corresponding executable, the number of times that the executable has been run, the size of the prefetch file, and so on and so on. One more thing is cache WhatsApp profile pictures. From the cache folder, you may find pictures of the suspect, the victims, and pictures sent in group chats. And in the end, browser history. You may find information on when a user last accessed WhatsApp web on their browser, such as the last date, time they visited the platform, the number of visits, and even the number of times the WhatsApp URL was used. Note, the WhatsApp desktop application or web client on Windows or macOS will not provide you with the volume of WhatsApp artifacts. However, what you get from WhatsApp on a computer is better than nothing. That's it for the presentation part, and let's continue with demo session. Let's start our demo with the first image extracted from Samsung Galaxy J3 with Android 5. Our researcher opens the backup file where we are looking for WhatsApp. We unselect all the folders in the list of folders and check Carve. We pick up only Chat folder, then in the right part of the window we pick up WhatsApp node and click Finish. The analysis procedure starts, and we see it in the Task Manager section. In the lower part of the window, you can see the procedure status. The process of Instant Messenger folder analysis is initiated. Here we will need a key file as our backup is encrypted. We repeat the action for every task. Let's have a look how our researcher is doing it. The Instant Messenger folder is analyzed. We see the outcome of the process on the screen. When the procedure is completed and we see the status of every task as successfully completed, we may get back to Case Explorer section. There are two ways to access a chat history: as a conversation view and as a table view. The table contains receivers and senders' names as well as timestamps and types of messages. There is also the image preview right in the Evidence Center user interface. Let's wait when our researcher will show it. Okay, so here is an attachment with previews. And there is a message containing a media file. In Properties section, you can find the file type. This one has MP4 extension. And in Properties section, you will find also additional information like file size or something else. Let's have a look at the other instances in this backup. Here you can see also the incoming call, even more images and messages. The next step is to have a look at our backup in file system. In WhatsApp folder, we can see databases subfolder. That's how encrypted msgstore.db files are stored in the database. The next backup we are going to analyze is a full file system image of iPhone 6s with iOS 12. Let's have a look at the first message in Chat History table. Evidence Center provides us with the senders and receivers' names. In the lower part of the Evidence Center window, you may see Properties section, which contains detailed info, including profile path. As I said during the presentation, iOS stores WhatsApp data in a single backup, chat-storage.sqlite. Let's also check the hex section. That's how a decrypted message looks like. We can read the text. The most informative parts of the chat storage SQLite database are message and media items. They store items containing data corresponding to messages, sender and recipient's timestamps, geolocation data, and so on. And here we can see some more messages containing some important data, including contact info. The other interesting table in the chat storage.sqlite database is contacts v2.sqlite, which contains info about user contacts such as names, phone numbers, contact statuses. And here on the screen we may see this information. And that's it for the part with WhatsApp for mobile platforms. Let's proceed to computers. First, let's open a WhatsApp desktop application in Windows 10. Type and send some random message in one of the chats. Here we can see how our researcher is doing it. Okay. Then we open the Chrome browser and WhatsApp in it, and make sure that for now WhatsApp is supposed to run only in one instance at a time. We also see that the chat history is identical in both instances, and here is the window of desktop application reminding us that we are already running WhatsApp in browser. Let's have a look what we have in Belkasoft Evidence Center in regards with WhatsApp. We create a new case. Right now we can see the process running on the screen. Then we select the C drive for analysis. And we go to the Task Manager section. Here we see the analysis procedure of the source by Evidence Center. In the lower part of the window, you may see the sequence of activities Evidence Center is doing as an analysis process. It's searching for different kinds of artifacts. For now, we will cancel the procedure as the process of analysis is lengthy, so for the further analysis, we will use the pre-built case. First, we open users directory and look for a WhatsApp subfolder among the other folders. Right now, our research is looking for a specific username subfolder, then app data subfolder, roaming, and here is WhatsApp subfolder at last. We may also find some WhatsApp data in Start Menu subfolder, which is the common place for LNK file storage. Our researcher opens Microsoft directory, then Windows folder, Start Menu, and WhatsApp. And here is an LNK file. There is a table containing various WhatsApp related data. One more place to investigate WhatsApp data is Program Files directory and Windows Apps subfolder. You can open it only with Belkasoft Evidence Center. In the search window, we are looking for the containing WhatsApp keyword. And here we are. We can see a folder. Click it and we are transferred to the WhatsApp desktop application subfolder in Windows Apps subfolder. As I said during the presentation, an important source of WhatsApp data is prefetch files. Let's search for these files in our case. First, we find Windows directory, in which prefetch folder is located. We will try to search for WhatsApp data in this folder, and as a result, we can see 4 files with the PF extension related to WhatsApp. And the last place we are going to investigate for WhatsApp artifacts is Browsers directory, which contains URLs subfolder, and here we can see a list of WhatsApp URLs including data like last visit time and page name, the link itself, and so on. Hope you liked demo session and content of the main part of the webinar. And finally, I'm going to provide you with some additional information. We have articles section on the website where you can find the latest content we created for you. I encourage you to read the newest article on WhatsApp. There is also a white paper section on our website where you will find one more useful piece of content on WhatsApp a white paper on WhatsApp forensics on mobile platforms. During our webinar, we have shown you a small part of Belkasoft Evidence Center functionality. In reality, Evidence Center contains tons of great features and allows experts to conduct digital forensic investigations in the most efficient way. Belkasoft flagship product functionality allows you to perform such tasks as mobile acquisition and analysis for iOS and Android devices, including iOS full file system extraction with a disruptive checkmate-based feature and agent-based acquisition method, as well as the support of a long list of Apple and Android devices and various iOS and Android versions. Analysis of PCs and laptops with all popular operating systems, remote acquisition, and this module allows you to perform acquisition of various data sources from remote locations. Available data source types include hard or removable drives, RAM memory, and mobile devices. The other tasks are acquisition and analysis of cloud storages, incident investigations, in-depth SQLite analysis, link analysis with communities detection, photo analysis, and even more features which are presented in Belkasoft Evidence Center. And if you are interested to test Belkasoft Evidence Center by yourself, you may always try our free trial. The link which you can use to download free trial version of Evidence Center is provided on the screen. Compared to other similar tools on the market, Evidence Center offers the most for its price. Belkasoft offers a very flexible pricing scheme, so our customers can choose the combination of features that fits their budget. We also have an academic version, which is provided with a very affordable price, with a discount up to 95%. And we are always here to help you and to answer all of your questions regarding the product and its functionality, as well as commercial questions. And one more time, I invite you to give your vote for Belkasoft Best of Breed solution, Belkasoft Evidence Center, on Forecast Awards website. The link is provided by my colleague in the chat. And thank you for your attention, and if you have any questions, please type it in the chat.